x minus y equals 2 and x plus y equals 4. So we're still going with the concept of getting a solution out of a linear system by looking at it graphically. But here I'm just going to graph the two equations first. Then when we graph them, we'll see at which point they intersect, and then we'll go ahead and identify that point, which would be the solution. So first I need to graph these 2 points. These 2 equations here. So you could go about any technique you like using. You could do intercepts, or you could just get it into slope-intercept form, which tends to be the popular case, so I'll just go ahead and do that. So to get this first equation here into slope-intercept form, I have to isolate y. So my goal is to get y alone, so I could identify what the slope and the y-intercept are, which is the m and the b. So to do that here, I'll start off with the first equation. So we want to isolate y, we subtract the x over first. So we got x minus y equals 2. To isolate the y, I'm going to subtract the x on both sides first. So these x's cancel. So we get a negative y equals 2 minus x. Now y is not alone because that negative there, so we could simply multiply this whole equation by a negative or divide by a negative, however you like doing it. I'll just go ahead and multiply this equation by a negative sign. So then y would equal x minus 2. So this is going to be one of my equations that I'm going to graph. So our y-intercept is negative 2. So I'm going to start right here at negative 2. And my slope is 1. So I'm just going to rise 1 and run 1. Right? Up 1 over 1. Up 1 over 1. So just to get a feel of what this line would look like. Okay, now we're going to work with the second equation now. So let me go ahead and erase this stuff here. Reduced to y equals x minus 2. We got into slope-intercept form. Now we're trying to do the same thing with this equation here. So we got x plus y equals 4. To isolate the x, we're just going to subtract the x over. So then these x's cancel out, and then we get y is equal to 4 minus x. And this is in slope-intercept form. If you want to write this with the slope starting off first, you could write it as negative x plus 4. There's no difference. So here I can see that my y-intercept is 4. And my slope is negative 1. So we're just going to go down 1 over 1, down 1 over 1, down 1 over 1. So it looks like that's the intersection point right there. So that looks like the intersection point, which happens to be 1, 2, 3 for the x value. So the solution would be in an ordered pair, and my x value would be 1, 2, 3, and the y value would be 1. So 3, 1 is the solution to these two systems of equations that we started out with earlier. I just wanted to, just refresh a little bit about how we graph lines. And then first we drew them out and saw the intersection point. So that's one way we got the solution out. So I hope this was helpful. And then I'm going to put up an example for you guys to try. Okay, so this is the last example that I have for you guys to try. Similar to the one that I just did for you guys. So go ahead and attempt it, and I'll go over it very quickly with you guys. Okay, so we're trying to get the solution to the system by graphing these two lines, identifying the intersection point, and then that'll be it for us because we know that the intersection point is the solution. So you could go ahead and about this any way you like, but I'm just going to do the slope-intercept again. So to get the first equation into slope-intercept form, we're just going to have to add the 2x over. So I'll just rewrite this here. Y minus 2x equals 1. So we just have to add the 2x over. These would cancel, then you would just get that y is equal to 1 plus 2x. And if you want it in a way where the slope, with the slope written first, you could just write y equals 2x plus 1. So this is what the first first equation here looks like in slope-intercept form. Now if we want to get this second equation to be in slope-intercept form, we're going to first subtract this x over, right? So I'm focused on this equation now. So we're going to subtract the x over because we're trying to get it into slope-intercept form. These x's cancel out here. So the 2y comes down. That's equal to 12 minus x. Now the y would be alone, but this 2 is still stuck to it. So we're going to do the reverse operation. And since it's being multiplied by 2, we're going to divide by 2. So these 2's would cancel here. You get that y is equal to 2 goes into 12 6 times. And then this is pretty much like saying half of x. And again, if you want it to be written in a way with the slope, starting with the slope written first, you could write negative half of x plus 6. So here we got y is equal to negative half of x plus 6. Alright, there we go. Let me just erase this stuff and then we'll get started. So this line here has a y-intercept of 1. And it has a slope of 2. So from this point we're going to go up 2 over 1. So just to get a general sense of what this one looks like, it would be like this. This one has a y-intercept of 6, so 1, 2, 3, 4, 5, 6 up here. And it has a slope of a negative half, which means we're going to go down 1 over 2. So down 1 over 2. The way I draw this is very poor, so it looks like that should have been the intersection point right here. I just don't know what I started doing there. So it looks like that would be the intersection point actually right here. So because the slope was, for this blue line was 2, so from this point we go up 2 over 1. And then from this point, again, we would go up 2 over 1, so we land on that line. So I just didn't draw it very well the first time. So it looks like that would be the intersection point right there. Okay, so that point right there would have a solution in an ordered pair as an xy. So the x value here looks like it's 1, 2. So it has an x value of 2. And the y value there seems to be 1, 2, 3, 4, 5. So 2, 5 would be the solution to this system right here. And we got that out by just visually looking at it and seeing what the interception point was.